as we discussed last week, as we discussed last week, Docker. Just again, I will briefly discuss about the Docker introduction for 5 minutes. Then we will get into in detail. As we discussed last week, Docker is a containerization platform. Docker is a containerization platform for developing and running, deploying and running our application. So it's a containerization platform which will allow us to package our application and all its dependencies together. It will allow us to package our application and its dependencies together in the form of containers. So Docker enable us to separate your application with infrastructure. So what does it mean? It will allow us to separate your application with infrastructure. What does it mean? Basically, whatever package we are going to create, Docker package, we can run in any infrastructure, whether it is on-premise server or whether it's a cloud infrastructure. We can run the Docker application in any infrastructure. There is no dependency, like it is not tightly coupled with the underlying infrastructure, because the package itself is self-sufficient. The package itself is self-sufficient so that it can run anywhere. As we discussed, Docker is lightweight. It doesn't require a hypervisor. Docker is not a virtualization technology. Docker is not a virtualization technology. So you don't need a hypervisor, and Docker doesn't require much system resources like CPU, RAM. Docker directly runs on the host machine kernel. Docker directly runs on the host machine kernel. Docker will allow us to quickly deploy and scale our applications. So we discussed last week again. I don't want to get into in detail what is difference between virtual machine and containerization. What is difference between virtualization and containerization? As we discussed last week, using virtualization, we are virtualizing at the hardware layer, at the infrastructure layer. At the hardware layer, we are virtualizing our system resources. So each virtual machine will have a complete operating system. Each virtual machine will have its own OS. As we discussed, virtual machines are heavyweight. Virtual machines are heavyweight, as it will have its own operating system. When it comes to containerization, if you see containerization, each container which we are running on this machine will use host system kernel. It will use host system kernel. Containers will not have a complete operating system. Container will not have an operating system. Containers are lightweight. It doesn't require much system resources because it doesn't have an operating system. Containers will use this system kernel, the host system kernel. Containers are self-contained. Basically, containers are basically a packages. Those are self-contained. Everything like whatever is required for your application to run, it will be having everything as part of the container itself. But again, one question, guys. Where our containers will run again? Where do our containers will run? If you see, where do our containers will run? Basically, on top of server only. On top of server only. But all the containers which are running in this machine will use this server kernel as well as this server's CPU and memory. So we discussed this, what is the difference between virtual machine and containers. Okay, so I don't want to discuss this again. So we will directly get into a Docker. So Docker. What type of tool it is? Containerization tool. So vendor is basically an organization called Docker. They are the vendors of this software, Docker software. Cross platform. Docker is cross platform. What does it mean? Can we install Docker in any operating system? Can we install Docker in any operating system so that we can run our containers? So yes, we can install Docker in any operating system. Docker can be installed in any operating system, whether it's a Windows machine or whether it's a Linux machine. Again, most of the Linux flavors it will support. Is it an open source? Docker is an open source? Yes, some extent, but not complete. Docker has coming in two editions. Docker is coming in two editions. Docker Community Edition, Docker Enterprise Edition. Docker Community Edition and Docker Enterprise Edition. So Docker is having two editions. One is Community Edition and one is Enterprise Edition. So Community Edition is open source. So this is open source, but Enterprise Edition, it's not an open source. Docker Enterprise Edition is not an open source, it's paid version. Docker Enterprise Edition is a paid one. So cross-platform, what is the meaning of cross-platform? As I told, it Docker is a cross-platform. What is the meaning of cross-platform? Can we install Docker in any operating system? Yes. So that is the meaning of cross-platform. Docker can be installed in Windows, Linux, Mac, wherever you want to install, you can install. So it supports all the operating systems. So Docker is having two editions. One is community edition, another one is enterprise edition. So what are the additional features we will get here? Right, we will get some additional features. When I go for a community edition, we will get some additional features. We will get so we'll get these additional features: universal control plane and Docker trusted registry. Basically, when we go for paid versions, right, there will be some additional features we will get. So what is DTR? What is UCP? We will discuss later. So these two additional features we will get in a enterprise edition, whereas in community edition we will not get these additional features. So before we try to install Docker, before we try to install Docker, we will try to understand the concepts, Docker terminologies at least. Before we get into Docker installation, we'll try to understand Docker architecture and Docker terminologies. So in Docker, we have these concepts or terminologies: Docker file, Docker image, Docker container, Docker volume, Docker networks, right? Docker swarm. At high level, Docker registry or repository. So these are the high level concepts or components of Docker. As we discussed, Docker is a package. Docker, using Docker, you can create a package that you can run anywhere. So Before Docker, before Docker, we have a SCM tools. We have a SCM tools like Git, GitHub, right? Source code management tool. Let's assume this is your GitHub. Developers used to commit the code as part of this. Let's assume your source code is there. Your source code is there. Your build scripts are there. As part of your GitHub, the developers will maintain the source code. The developer will maintain the build script, like all the Java classes, and build script like pom.xml if it is a Java based project. Developers used to maintain source code. Developer will maintain the source code as part of the version control system tools like Git, GitHub. And if I want to build and deploy this application, if I want to build and deploy this application, what we used to do, we used to clone this. Basically, we will pull the code, will pull the code. If it is a Maven based, Maven based project, like Java based project, and they are using Maven as a build tool, using build script, we used to generate a package, application package. We used to generate an application package like a jar file or var file, right? Application package. What will be the part of our application packages generally, whether it's a Java project or .NET project or whatever it is? What will be part of our application packages? What will be there as part of our application packages? What will be there as part of our application packages? So application package, only it will be source code, guys. Only source code. Application package will contain only source code. Only source code. Does it have like the softwares, like whatever software is required to run this package? Do we have as part of this one? It's just an application package. Jar file, var file, if you take whatever like other programming languages also, only source code, compiled source code. Suppose this I want to deploy. This I want to deploy in some server. Suppose this package I want to deploy in some server. This is my deployment server. This is my deployment server. It may have some operating system. This is my deployment server. Some operating system, OS. Can I deploy this package as is without configuring this before Docker? Is it possible to run this software? Basically, is it possible to run this package in this deployment server without required softwares and configurations? No, right? This is just an application package. This is just an application package. You need to install, basically you need to configure required softwares in this server. You need application softwares. You have to install application softwares, whatever is required to run. Suppose this package is basically a jar file, Java based jar file. You need to have a Java software installed. If it is a WAR file, you need to have a software like Tomcat or JBus to be installed. Then on top of this, I can run my application. On top of this, I can run my application. This is before Docker. We discussed already in the last class. Suppose I have another application. Will I able to run this application? Another application without impacting this. Without impacting this, we can run multiple applications. But what is the meaning here? I want to isolate this application from here. Suppose this application requires different Java version. This application requires a different Java version. Can we do this? Suppose this application requires a different Java version. This application requires different Java version. In a normal systems, is it possible to have a two applications which is running on a two different versions, two different configurations? Are you getting my point, guys? Suppose this jar file requires, I want to run this application on Java 7, let's assume. This application I want to run in a Java 8. And different JVM settings. For this one, I want to have a different JVM settings. For this one, I want to have a different JVM settings. Is it possible? And if something goes wrong with the JVM, if something goes wrong with Java, it should not impact this guy. If something goes wrong with Java in this application, it should not impact this application. So this is not possible in a normal servers, normal virtual machines or physical machines. And also, what is the one more challenge? Suppose same package, if I want to deploy, I want to share with other team or other server I want to deploy. Suppose this is my production server. Can I run this package again as is here? It's not possible. Again, you need to configure this server. Again, you need to configure this server. You need to install the required softwares. You need to set up required environment. So again, you need to configure this server and you need to run. And sometimes sometimes this software, this application package may work here and it may not work here. If you are from a development background, you might have faced these issues. If you are from a development background, you might have faced this issue. Same package, application package, may work in one server, may not work in other server. So what is the problem? What might be the issues as we discussed? This, your infrastructure and your dependencies for this software is getting changed. So this is how we used to do before Docker. Now, when we have a Docker, when we use Docker to build and run our applications, when we use Docker to build and run our applications, what we will do, what we used to do. So again, developer will commit the code. Basically, developer will maintain the code as part of source code repositories. Now, as part of your build process, you will generate your application package. On top of this application package, we will create a one more package. On top of this application package, we will create a one more package. We call it Docker image. As part of your build process, you generate an application package. As part of your build process, you will generate an application package. And also, you will generate Docker image. What is Docker image? Docker image will have required dependencies. I mean to say softwares, required dependencies, and this application package, required dependencies and application package. We have to generate this one, your application package. In case of Java, it can be jar or var, right? Something like this. Whatever dependencies is required to run this application, right? That one plus our application package. So we'll create a Docker image. So how can I create a Docker image? What is required to create a Docker image? If you understand the Docker terminologies here, we have a Docker image. Docker image is nothing but a package. Docker image is nothing but a package which contains required software plus your application. So what is required to create a Docker image basically? So you need a Docker file. So we have to write a script. We have to write a script called a Docker file. So we have to write a script called Docker file. So the way you have a build script for your application software, similarly you have a script to create a Docker image. So we have a Docker file. Docker file is a file, basically which contains instructions to create an image. So Docker file will contains the commands, basically the instructions, right? Docker file contains the instructions to create an image, Docker image. So Docker file is a file, text file that contains all the commands to create an image. So first question, who will write the Docker image? Who will create a Docker image, right? So who will write the Docker image? This is the first question, right? Whether developer will write the Docker file, or as a DevOps engineer, we need to write a Docker file. So as a DevOps engineer, we have to write a Docker file. Most of the cases, as a DevOps engineer, we are going to write a Docker file for that application. In some projects, some projects, developer may also write a Docker file, but most of the cases, DevOps engineer, as a DevOps engineer, we need to write a Docker file. So in which programmatic language we will write? In which programmatic language we will write? We will not use any programmatic language. One minute, just give me 1 minute. So as a DevOps engineer, we will write a Docker file. In which programmatic language we will write? We will not use any programmatic language. Which contains, Docker file contains instructions. So what type of instructions, right? So Docker file will have instructions. Docker DTR, basically, sorry, Docker domain specific keywords. Domain specific keywords. Docker domain specific keywords. So domain specific, like if we have some keywords like from, copy, add, run, cmd, entry point. Just to give an example, these are the Docker domain specific keywords. So Docker file we will write using these domain specific, Docker domain specific keywords. Each keyword will have some meaning. Each keyword will have some meaning. Suppose if you are from SQL background, in SQL, select has some meaning, right? From will have some meaning. Table will have some meaning. Where will have some meaning. If you are from a SQL background, right? How are you going to write a SQL queries? Something like procedures, functions. You will use some domain specific keywords, right? In SQL, you have something like select, from, table, where. In the background, it will perform something, but we are not worried about what is happening in the background. We are using domain specific keywords. HTML also, if you see, you have a head, body, right? Root. These are HTML specific domain keywords. Similarly, in Docker, we have a Docker file. Using that, we are going to create an image. So that will have these instructions. Domain specific keywords. There are a lot of keywords. In a separate session, in future sessions, we will discuss in detail about all these Docker file instructions. In detail, we will discuss in a future sessions what is from, what is copy, what is add. There are a lot more. We will discuss in detail. It contains instructions to create an image. We are not going to write any programmatic language like shell script, Python or Java. It contains the domain specific keywords. So we will write a Docker file and we will maintain the Docker file as part of the source code itself. So now you create an application package. After that, you need to create a Docker image. We are going to create a Docker image. So this is Docker image, which contains required softwares and our application. Guys, can I use Docker to build any programmatic? Can I use Docker to build and apply any application which is developed in any programmatic language like Java language or .NET language, Python, Node.js, or is it going to support only Java? So we can use Docker to build and deploy applications which is developed in any programmatic language. We can use Docker to build and deploy the applications which is developed in any programmatic language, whatever programmatic language. There is no change in the Docker concept. There is no change in the Docker concept. If you want to build and apply Python programmatic language, still you have a Docker file. You need to create a Docker image. So this Docker package, if I want to build and deploy Python programmatic language, I will have a Python software and Python package as part of this image. So Docker can be used for any programmatic language. So Docker file, using Docker file, you are going to create an image. What is Docker image? It's a package which contains everything to run a piece of software. Basically, everything to run a application. It contains everything like softwares, if required, like environment plus application code. It's a package which is created using some Docker file. So we have a Docker image. Now what is container? What is container? You have a Docker file. Using Docker file, you can create an image. What is container? Container is basically, it's a package. If you just create a Docker package, does it mean your application is deployed? Suppose I just created a Docker package, Docker image. Does it mean does it mean our application is running? The moment I create a package, does it mean our application is running? It's just a package. So container is basically runtime instance of an image. If you run Docker image, container will be created. That is where our application is running. It's a runtime instance of image. I have an image. If I run that image, container will be created. That is where our application will be running. It's a runtime instance of your image. So this is my Docker image. From this image, if I create a container, that is where our application will be running. Now, this is my Docker image, Docker package. How can I share this package? How can I share this package? How can I share this package to anyone, whoever want to deploy this application? Suppose now, this is my deployment server. This is my deployment server. It can be a physical machine, or it can be a virtual machine, or it can be a cloud. It can be a cloud instance, whatever it is. So you have an operating system. On top of this, basically, you have an operating system. Now I want to deploy this package, Docker package. So how can I share? Basically, how can I move this image? Right? That is where repositories comes into picture. Docker registry or repositories. Basically, what is the purpose of repositories, guys? We already discussed, like as part of our training, right? We already discussed repositories concept, right? What is the purpose of repositories? Like we already discussed Nexus repository or Artifactory. What is the purpose of repositories or artifactories? To store the packages, to store the packages, right? To store the packages. Guys, source code we will not maintain in the artifactories. Are we going to maintain the source code in the artifactories like Nexus, JFrog? Are we going to maintain the source code in the artifactories like JFrog, Nexus? Source code will be part of your SCM tool. Source code will be part of your SCM tool like Git, GitHub. What do we maintain in the artifactories? It's a package, application package. Only the application packages. Now, similarly, this is also one package, right? This is also one package. Docker image also nothing but a package. I can maintain these packages in the repositories or artifactories. I can use public repositories or I can use private repositories. So, public repository or private repository. We have Docker Hub. So, Docker Hub is a public repository. I can maintain in a public repository or I can maintain in a private repository. This package. So, I can push the package. I can push the package so that this Docker package image will be pushed to the artifactories. Basically, this is repository. So now I created an application package and I push that application package. I push that application package. Sorry, I push the Docker package, Docker image. Suppose now here I want to deploy. Here I want to deploy. Can I pull this? Can I pull this package here and can I deploy it as a container if it is there here? So this is my build server. This is my build server. As part of build server, as part of build process, we created a Docker image and we pushed the Docker image. Now this is my deployment server. In my deployment server, I can pull this image. Docker pull. I can give a image name. Docker pull. So image is now here. From this image, I can create a container. I can create a container. From this image, I can create a container. From this image, I can create a container. But what software is required, guys, to pull the image, to create a container in this machine? What software is required? Can I directly pull and create a container? What software is required to do this? On top of your operating system, what software is required? You required a Docker software. Guys, please be on mute. If you have any questions, please Ask the questions in the chat box. So now I can pull the image and I can create a container. Do I need to configure any application software, guys, to run this now? Do I need to install anything here like Java, Tomcat, suppose, if I want to run this application? We just have a Docker. This package itself has everything, right? This package itself has everything. Java software, Tomcat software if required. So this is where our application is running. Now can I deploy another application in the same server from a different image or same image? Suppose I have another application. I have another application. Can I create a one more container here? Without impacting this application, can I run another application in this server? So you create a Docker image, you create a Docker image, you run the another application. This is application 1 container. This is application 2 container. You can run n number of containers. But can I create a container without image? Can I create a container without image? What is the input for your image? Sorry, what is the input for your container? What is the input for your container? Basically, image. Now, if something goes wrong with this process, Tomcat process is running, let's assume Tomcat process is running here. If something goes wrong with this container, will it impact this guy? If something goes wrong with this container, will it impact this guy? It will not impact. Does each container will have a complete operating system, guys? Inside this container, do we have a complete operating system? Does each container will have a complete operating system? No, right? So what is common for all the containers which are running in this machine? What is common for all the containers which are running in this machine? Suppose if I have another container, what is common? Basically Docker we are using, but what is common, right? All these container will use this kernel, this operating system kernel. This kernel, all the containers will use this operating system kernel. And what about CPU memory, right? All the containers will use, they need some CPU, they need some memory, right? You are running one process, you are running Java process, you are running Tomcat process, or maybe you are running database process, database container, database also you are running as a container, maybe MySQL. Does this process require CPU and memory? Right? So what is common for all these containers? Your host system kernel and your system resources. Your system resources. What is resources? Your system resources? CPU, memory. All the containers will use the CPU and memory from this host machine. All the containers will use this host system kernel. But it will have its own user space. It will have its own user space, network space. This will have its own user space, network space. but common is this system kernel, CPU and memory. One of the interview question, in lot of interviews our students got this question: how many containers we can run in one system or server? How many containers we can run in one system? This is one common question. How many containers I can run in one system? Is there any limit? Right? That is depends on what? It depends on your system resources, CPU and RAM. Your system resources. Suppose I have a 1 GB RAM. Based on your system resources, suppose I have just 1 GB RAM and 1 core processor. Maybe if I create 4 or 5 containers, suppose I can create maybe 3 or 4 containers. This container is taking, let's assume 200 MB. This container is taking maybe 100 MB memory. This is taking maybe 300 MB. This is maybe taking 200 MB. And if I try to create a fifth container, will it work? If I try to create a fifth container, will it work? Your server itself doesn't have enough resources. It will not work. Your server itself doesn't have enough resources, so it will not work. So that is based on your CPU and memory, your system resources. Now I deployed my container here. I deployed my container here from the image. So if I want to deploy this one in a production server, this is my production server. This is my production server. Do I need to configure any application software except Docker? This is basically Docker. This is not your application software. Right? So do I need to install and configure any application software in my production server? Not required. Here also what you can do? Here also you can pull your image from the repository. Pull your Docker image in here basically, and you create a container. Basically you create a container. You pull a Docker image and you create a container. Now if it works in this server, definitely it is going to work in this server. If it works in this server, it is going to work in this server also. That is because from the same package, the package itself has the softwares, your configurations, your application code. With the same package, I am creating a container here. If it works here, it is going to work here. Build once, run anywhere. Build once, run anywhere. So now if you understand the concept, Docker file, you need a Docker file. We are going to create a Docker image, and we are going to maintain the images in the Docker repositories. We are going to maintain the images in the Docker repositories. That can be public repository or private repository. Like using Nexus also I can create a Docker repository. Using JFrog also I can create a Docker repository. If I go for enterprise edition, as I told, if I go for enterprise edition, I am going to get one software, licensing software. DTR. What is DTR? If I go for a Docker enterprise edition, I am going to get one licensing software. Docker trusted registry or repository. It's a private repository. What we will do with these repositories, guys? What is the use of these repositories? To store and share the images we will use Docker repositories. We can store and share the images. We can store and we can share the images using Docker repository. It's a central server. It's a central server using which we can share, we can store and we can share the Docker images. So all the images will use host system kernel, right? Just host system kernel. But is your application software and its configuration is part of this image itself. Your application software and its configurations is part of your image itself. What is kernel basically? What is the role of kernel, guys? What is the use of kernel? It's an intermediate layer between the hardware and the software. It will convert that human readable code into a machine readable code. Right? It's a medium between hardware and software, right? So containers will use just host system kernel just to convert that human readable code into a machine readable code, right? It will act as a layer between your hardware and your software, right? So most of the times the kernel will not impact your application, your container. But one thing to be remember, guys, suppose I want to run Microsoft .NET applications, Microsoft .NET applications. There are two types of containers, Linux containers, and Windows containers. There are two types of containers, Linux containers and Windows containers. Suppose if I want to run Windows containers, will it work on a Linux servers? If I want to run Windows containers, will it work on a Linux containers? Basically Linux servers? Suppose I want to run Windows containers. Basically, Windows containers, suppose you have a .NET code. .NET is basically a Microsoft product. So it needs Windows capabilities, right? So in that case, how can I run this one? But in Windows machine, we can run a Linux containers. In Windows machine, you can run a Linux containers. If you want to run Linux containers in your Windows machine, what will happen? As I discussed last week, when you are installing Docker in Windows, it will create one Linux VM. On top of that Linux VM, containers will be created, Linux containers. Suppose if you install Docker in Windows machines, there is an option. There is an option. So you can select enable Windows containers. There is an option. The moment you install Docker in your Windows machine, there is an option to select what type of containers to run, whether Windows containers or Linux containers. Suppose if you want to run .NET related stuff that will be running on top of Windows containers, so you have to enable that one. You have to enable that one. But most of the times, right, we will be using Linux containers only, because .NET is not open source. .NET is again commercial. So most of the projects will prefer open source. So there is an option, if you are installing Docker in Windows machine, there is an option to enable. I have not installed, this is not Windows machine. So while installing this one, while installing this Docker for Windows, right? If you want to run Linux containers, you have to enable a Hyper-V. You have to enable a Hyper-V. The prerequisite is you have to enable the Hyper-V. You have to enable the Hyper-V. So once you install, you will get an icon like this. In your Windows laptop, you will get an icon, icon like this. If you want to run Windows containers, you need to select, you need to go to that settings, you need to select an option, right? If you want to run Windows containers, basically .NET related images, .NET related images, if you want to run, you have to enable a Windows containers. That option you will get once you install Docker in your Windows machine. So now let's understand this Docker file, Docker image, and Docker container. Docker container is a place where our application is running. So we will discuss what is volume, what is networks in a individual sessions. In a future sessions, we will discuss what is volume, what is network. Now let's understand the flow. Let's understand the flow. From the Docker file, we are going to create a image. From the Docker file, we are going to create a image. From the Docker file, we are going to create a image. If I deploy the image, what we will get? If we deploy the image, what do we get? If we deploy the image, what do we get? We will get a container. That is where our application will be running. So from this Docker file, we will create an image. That image, we will run it as a container. Where can we maintain these images? Where we maintain these images? Suppose I want to deploy in some server, I want to share with some other team, where we will maintain these images in the repositories, in the Docker repositories. So why containers? What is the advantage? As I told, what is the advantage with containers? We can quickly create ready to run applications, right? The advantages is it will improve the efficiency, build and deployment. We can quickly create ready to run applications, ready to run applications. And is it saving the time? Containers, is it saving our time to build and deploy our applications? Right? It's saving our time. Right? We can quickly create and deploy our applications as a containers. And also, is it reducing the cost, infrastructure cost? Because I can fully utilize our servers. We can fully utilize our servers. I can run multiple applications in a same servers if I use containers. I can fully utilize our infrastructure. So it is saving the infrastructure cost. And does it require more CPU and memory? Does container requires more CPU and memory? It's not required because does container have a complete operating system or only the runtime which is required to run our application? Only the runtime which is required to run our application. So it will improve the efficiency, and also it will reduce or eliminate platform compatibility issues. It will reduce the or eliminate the platform compatibility issues, like it works in dev, it don't work in production, right? It will reduce or eliminate platform compatibility issues. Most importantly, why Docker is very hot in the market now? Why Docker is very hot in the DevOps market, and why there are a lot of demand for people who knows Docker? That is because of this microservice architecture. If you see any project nowadays, it's a development concept. The development team is nowadays they are following a microservice architecture. In future classes, we will discuss that. So Docker and Kubernetes is very demanding tool in a market because everyone is following a microservice architecture to develop the applications. So Docker will shine for a microservice architecture. So support next generation applications called microservices. Developer will care because of this. Developer can quickly build and run the applications. It will support microservices architecture. So it will reduce or eliminate compatibility issues. And why operations cares? DevOps, operations team. Why we care? Why we choose containers? Why we prefer containers? Because it will improve the speed and frequency of releases. So it is like create once, run any times, right? Eliminate environment inconsistencies, right? And if required, we can scale up, scale down our applications as a containers. So we care because it is eliminating the inconsistency between the infrastructure and it is improving the efficiency. Now, before we install Docker, now let's understand the Docker architecture. Before we install the Docker now, we understand the architecture. If you see Docker at high level, we have three components: Docker client, Docker host or Docker daemon or Docker server, and registry. Docker contains three components: Docker client, Docker daemon, basically your Docker software or Docker server, and Docker registry. What do we do with client? Docker client, Docker CLI. So Docker client, Docker CLI or client. Whatever commands we are going to execute, Docker build, Docker push, whatever commands we are going to execute, these commands, who will process these commands? Whatever commands we are executing using Docker CLI, client command line interface, who will process these commands? The client will talk to the Docker daemon, it will process the commands. The client will talk to the Docker daemon and it will process the commands. Suppose if I execute, guys, here also you need a Docker. Suppose here I am executing Docker build. There is a CLI here. That CLI will talk to the Docker in this server. The CLI will talk to the Docker server, Docker daemon. Whatever commands we execute, the commands will be processed by a Docker daemon. If I try to create an image, request goes to the Docker daemon, Docker software, that will create an image. If I execute Docker run, it will create a container. Docker CLI, basically a command line interface, and Docker daemon or Docker host will process these commands. It will create a images or it will create a containers. And what is registry? What do we do with registry? As I told, what do we do with registry? Registry or repository, we will store, we will maintain, basically we will push or pull the images. It's a central server where you can maintain your images. So now there is a public repository called Hub, Docker Hub. There is a public repository called Docker Hub, hub.docker.com. What is this hub.docker.com? Like, it is one repository. What is there in this repository? So what is there in this repository? Basically, there are images. But is it a public repository or it's a private repository? This Docker Hub. We have one repository, public repository. Public repository. Anyone can pull and push the images here. Guys, suppose you want to install some, application in your, you want to install one application in your mobile. Suppose you want to install one application in your mobile. Where do you, from where you will download that application in your mobile? Suppose you want to run one application, one mobile application, Play Store, right? So Play Store will have some applications, Android based applications, right? Like similarly, Docker Hub is like a Play Store where you can see all the softwares as a images. Suppose now I want to run Tomcat as a container. Suppose I want to run Tomcat as a container. Do you see this image? Tomcat image. If you want to run Tomcat as a container, do you see this image? Tomcat image. Suppose I want to run Jenkins also as a container. I can run Jenkins also as a container. Now do you see Jenkins here? Image. Suppose I want to run database like MySQL. So can I, if you see, MySQL also available as a Docker image. I can run database also as a container. These are public images. It's like a Play Store for our Docker images. Who created already these images? Who uploaded these images to this repository? If I see Jenkins also there as an image. Suppose if I want to run Sonar Cube also available as an image. If I want to run Sonar Cube, I can just create a container out of this image. I can just create a container out of this image so that Sonar Cube will be running as a container. So who created all these images? The respective organizations, right? So Tomcat, this might be created by Apache Foundation. They have written a Docker file. Using that Docker file, they created an image. So it's a public repository. And we can maintain our own images also. You can push your own images also, but in real time, we will not use public repository to maintain. So this registry is nothing but a public repository like Docker Hub or private repository using Nexus or JFrog or DTR. You can store images. This can be public Docker Hub. This can be a private Nexus or JFrog repository. So that you can pull and push the images from the repositories. You can create your own repository here. So before coming to tomorrow's class, I am expecting you to create one account. In this one, so that you can push and pull images from this repository also. First, we will use public repository. Later, we will see how to use private repository. So before coming to tomorrow's class, try to create one account in the Docker Hub. Guys, you no need to provide credit card, debit card. You no need to provide credit card, debit card, any details. Just give one ID, like something like this. One ID, whatever you want to give. Your mail ID, one password, so that you can create an account. And you will get a confirmation mail to your email. You will get a confirmation email. Try to accept that so that your account will be created. So Lakshmi, we are just starting Docker, right? Docker will be there for next 10 to 12 days. So we are just understanding a concept like what is the flow, how to build, and how to deploy. That we will discuss slowly. First, we are understanding the concept. Without understanding what is Docker repository, what is container, right? You cannot understand this. The process we will discuss in a future classes. So I'm expecting you to create a Docker repository. Installation, I will explain tomorrow. I thought of explaining today, but it is already late. It's already 7:30. So we need to close our session. So installation, I will explain tomorrow. Try to create a Docker Hub account. And meantime, how to build and deploy, you can go through this video so that you can understand at least in real time. Someone is like asking, try to go through this video. You can understand how to build and deploy the applications using Docker here in this video. I am sharing that link. It is there in our YouTube channel. Try to go through that video so that you can understand how can we use Docker to build and deploy our applications. So tomorrow we will continue, guys. So it's kind of a theory today also, but tomorrow what we will do? We'll try to create some Docker file. We'll try to create an image and we'll try to deploy our image as a container tomorrow. So tomorrow we will install Docker. We will build an image and we will deploy. We'll create a container and we will see how can we access. Okay. So tomorrow we will try to do this, guys. If you have any questions, any queries, let me know. We can discuss for next 5-10 minutes. Else we'll continue tomorrow, guys. Feel free to ask the questions. If you have any questions anytime, you can ask in the chat box while discussing the topics, or at the end of the session, you can ask if you have any question.
Sir, one question: how shell script will come into picture when we started this Docker containers?
How shell script will come into picture? Suppose you want to install some softwares while creating an image. While creating an image, you want to run some commands. You can create a shell script and you can run that shell script while creating an image. Right? Suppose not only forget about Docker, suppose you have a Docker containers, Docker servers, and you want to automate something in your server. Suppose you want to see how many containers are running, and you want to gather something from multiple things. Right? You can write a shell script and you can execute that shell script in your servers. Or if you want to run something while creating a image, you can write a shell script and you can run that shell script while creating an image. Shell script is basically for executing multiple tasks, right? Multiple commands. You are going to write those commands as a script so that you can run that script.
Okay, good.
Okay, guys, I share this link. Otherwise, just go to Google, just execute hub.docker.com, create one account. Tomorrow, I will show you how to install Docker. Then we will slowly understand how to write a Docker files, how to create a containers, what is volumes, what is networks. We will discuss in detail in future classes. So I will share the running notes and I will share the documents, whatever documents where I am trying to show it here in the groups. Okay. So please go through the document. Please go through the running notes and we'll continue tomorrow, guys.